Hey, what's up, guys? Yeah, just for fun, let's solve these two 111 minimum operations to make the array k increasing. Okay, so actually these problems I solve, I go to online and try to find a solution. Okay, so you are given zero index array consists of positive integers, positive in the array k, and the array is called k decreasing if I minus k less or equal to I, array I holds for every integers. I greater or equal to n, k less or equal to n minus 1. So the example is 4, 1 to let's say 4, 1, 5, 2, 6 is a 2 decreasing because this less than this and this less than this, right? So you can take 4, 5, 6, 1, 2, 2. These are both non-decreasing array. Okay, and you can change any array. You can pick any indices and change however you want. Okay, and you need to return a minimum number. For example, if you had a decreasing array, 5, 5, 4, 3, 2, 1, k equals 1, you only need 4, right? You need to make every guy become a 5, 5, 5. Okay, so this is the first way. And this one is 0. And for this k equals 3, let's maybe do this as an example, right? So 4, 1, 5, 2, 6, 2, 5, 2, 6, 2, right? So k equals 3, so you take these, right? And then you don't get anything, right? So you get 4, 2, 1, 6, 5, 2 pair. And this is non-decreasing, right? So you need to make you need to make it like 4, 4. And then this is okay, so it may be 5, 5, right? So we need 2. Okay. So the first step that you understand is what this problem actually this case just camouflage, right? Because this is a divine this is just a divine conquer, right? Because you know that, for example, let's say I fix k, I know that my condition is that array 0 less or equal to array k, array 2k, right? So this is the first sequence, and the second is that array 1 less or equal to array k plus 1 less or equal to array 2k plus 1. And then the third sequence is that array 2 less or equal to array k plus 2 less or equal to array 2k plus 2, right? Keep going. So this means what? So how many of them? Right, it's k minus 1 of them, right? This is a simple simple arithmetics, right? So k minus 1 of them. Okay, so your goal is to, so this problem now become just, well, once we do this reduction, this problem becomes that you just get k minus 1 arrays. K minus arrays. You need to make non-decreasing. You need to make it non-decreasing. And this problem is it's just simple, right? So the answer just be, let's say, I from 1 to k minus 1, and for each array you find a make an array non-decreasing, right? So minimum number. So you need to just return a minimum number to make. Yeah, so I don't want to write down, but you understand what I'm saying, right? So now this is original problem. Now it become a k minus 1 subproblems, and they are all independent, right? By definition, they are all independent. So we just, so our problem becomes somebody give you an array, and you just need to make it non-decreasing, right? So this just exactly k equals to 1. Okay. So we need to solve these subproblems. Okay. And this subproblem is actually another problem called the longest increasing subsequence. So the idea is that somebody gives you a sequence, right? And you try to make it, try to find the longest increasing one. The idea is that now you have an array, right? If you find the longest increasing one, maybe this, maybe this, or maybe this is the longest increasing one, right? Then the only thing you need to do is that make the rest change, right? Because this is the longest increasing one, right? So if you use less than longest increasing one, then it will give you, then you need more, right? So actually this problem for k equals to 1, that we just need the longest increasing subsequence. Okay. So the key point is that suppose you can find the longest increasing subsequence, and the minimum operations you need to do. Let's say this array is length n, just the length n minus this the length of longest increasing subsequence of array. Okay, so this is we find out this is the comma technical reduction. Okay, so let's quickly review how to solve this longest increasing subsequence. Okay, there are two ways. Yeah, So the first way, is using I think use DP. So I don't want to talk detail, right? But if you use a DP, then you need n square. I think the n square time to make it, right? However, this problem has 10 to the 5, right? So if you use the n square algorithm, probably you cannot solve it. Probably you get time limit out, right? So maybe the other way is using this ON solution basically is bisect one, right? So let me just quickly. So bisect one means that for each guy you just find bisect left. You just try to put in. It's like the greedy algorithm, right? So let me just describe one example, and then once I do this, then we can just directly solve original problem. Okay, so let's say 10, 5, 3, 7, 101, 1118. And we need to find the longest common, the longest increasing subsequence, right? So let's input 10, and you see 9, right? So 9 is, if you try to bisect left, then it becomes here, right? It becomes here, right? So you can replace this, right? It's greedy. So 2 is less than 9, so replace 5. 5 is okay. 3 is insert here, right? So you can replace this. 7, 1 is too large, right? 18 is okay, right? So you get the 4. Right, so for each step, you just bisect left, or basically binary search. Okay, so this is algorithm that d equals 0, and then for x in nums, you just bisect left, and then you got length d and append it, and then you just return length d. Okay, so you can just copy this length of LIS into this problem, right? So we put in here, and then there are 2 modifications. The first modification is that in this longest increasing subsequence, I require it to be strictly increasing. Right, but this problem is not need to be increasing, not need to be strictly increasing. So in this problem, actually, we need is the non-decreasing, right? We only need non-decreasing, not we do not need the strictly increasing. So for this original, we have left, right? And we just in this guy just change it to right, right? Because I don't need so 1, 2, 2 is okay. I don't need to change it to 1, 2, 3. Okay, and the final results, I need to return a minimum number, right? So I need to return the length of nums minus length d. Okay. So now we have the reduction technique. Then we can separate into k minus 1 different results. Okay, so that's n to be length of array. And if k equals to 1, I just return the results. Right? K equals to 1 is just what I get. And I initialize the answer to be 0. Now I separate into k minus 1, right? So for I minus in range k, each array looks like array jk plus I, right? Because I from 0 is the marginal 0 term, I from 1 is the mar 1 term, I from 2 is mar 2 term, up to I k minus 1 term, right? So array jk plus I. And then for j in range, minus I divided by k plus 1. The reason is this, right? Because now our array looks like jk plus I form, right? And these need to be less or equal to I minus 1. So your k need to be less than or equal to n minus 1 minus I divided by k. Okay, so your j should be to choose to be this. Okay. So your j up to n minus 1 minus I divided by k plus 1. And then you just add the answer, right? So for each one, we separate into k minus 1, okay? And then we return answer. That's it. Yeah, so this is the answer, right? So the idea is that, let me just recover the idea. So the idea is that we have the problem, right? And we separate into k minus 1 subproblems. Okay. I actually say k minus 1 array. Okay, so let's say if k is, especially if k is 1, this problem is exactly reduced to this LIS. If the k minus 1 subproblem also k minus 1 LIS. Okay, or basically the k. Okay, k subproblems LIS. Okay, so this is the beautiful application of reduction. Okay, and yeah, that's it. See you guys. Yeah, you can copy this code. I will post below. See you guys next videos. Subscribe to my channel.